Hey everyone, and welcome back to the Eclipse Community Meetup. I'm your host, Stephanie Swart, and today is the 8th webinar in our Eclipse Photon Series. With 85 projects, 246 committers, 73 million lines of code, and 620 contributors, Eclipse Photon is set to release June 27th. But before then, we are showcasing some of the projects that will be included in the release. So today, I'm joined by Nikhil from Goldman Sachs, who's presenting Developing with Eclipse Collections. So without further ado, Nikhil, take it away.
Thanks, Stephanie. Hi, everyone. This is Nikhil. I am the project lead of Eclipse Collections, and today this is our first release where Eclipse Collections is participating in Eclipse Photon. So we are very excited about it. And over the next hour or so, we will go through what exactly is Eclipse Collections, how you can develop it, and so on and so forth. So uh, let me share my screen. And all right then. So again, thanks everybody for joining me. Today we are going to look at developing with Eclipse Collections. My name is Nikhil, and I'm the current project lead of Eclipse Collections. So before I start, I do want to thank the entire Eclipse community for helping us with the Photon integration. The entire committer team was pretty much new to the whole Eclipse infrastructure. So thanks a lot, everybody again. Uh, so what's in the agenda? We're going to look at what is Eclipse Collections. Then we'll go through how you can learn the framework, check out who all is involved, and we'll end with some live coding demos. So what exactly is Eclipse Collections? Eclipse Collections is an open source Java collections framework. The USP of that is it has a functional, flow, and friendly, and a fun API. Like it has intuitive methods on its collections. It also provides slew of uh, a whole suite of its own collections frameworks as well, along with primitive collections. It is a fairly mature library. It has been under the development for it started internal to Goldman Sachs in 2005 when it was called as Caramel. It was open sourced in 2012 under the name of GS Collections, and it was the first open source project from Goldman Sachs. In 2015, we migrated to the Eclipse Foundation and rebranded it to be Eclipse Collections. It has approximately about 10 million lines of code. Most of it is code generated, and we add more and more features in every release. Um, how will you actually go about learning Eclipse Collection? So you can try out our Eclipse Collections kata. So kata is a martial arts term, and it's essentially where you learn new concepts via practice. You learn a concept, then you use it in practice, and then you keep on honing your skills over and over again. Similarly, we have the Eclipse Collections code kata, and code kata is where you learn concepts about coding, and you end up applying them and understanding how things work. The way the kata is set up is it is set up as a series of failing unit tests, and you as you go through each section, you get to learn new concepts, and your task is to make them pass using Eclipse Collections. We will be using the I will be using the kata during this presentation for the live demo. And so you can see what I'm going to do is I'm going to start with the download, and then pull it up in Eclipse Photon, and then go on from there. Uh, so who all is involved? The Eclipse Collections maintainer team consists of 5 experienced committers. We have been pretty much with the project since some of them have been with the project since its inception, then through its period of GS Collections, and through its period of Eclipse Collections. Currently, there are 41 contributors as of this morning. I actually had to change the slide right before the presentation started because there were 40 till last night, and we did get a new contributor last night. So it's pretty awesome. We are getting new contributors from different aspects of the community, and again we are really open to helping out to new contributors, to whoever basically wants to be involved. We will help them out. as much as we can, and we will be happy to have more people involved in this. So how can you actually get involved? As I said, we welcome contributions. We do have a contribution guide, and the hyperlinks actually take you to each of these web pages. And on the video, we have also collated all of them together as resources, so it's easy for you to refer to. Uh, Again, we are welcoming new contributors pretty much on a very frequent basis, and contribution is not necessarily in the form of code or in the form of pull requests. We believe that contributions can be in the form of even documentation, like if our reference guide needs updating, feel free to update that. If you find something while you're using the framework that has a bug, like feel free to report it. Again, like that's the power of open source. It's not necessary that once you report it you have to fix it. There can be somebody else fixing it, or even better, you can fix it, and we'll help you through that. If there are a few things which are lacking in the framework, feel free to raise feature requests. We do we essentially we look at the future feature requests, and what we do is we end up marking these issues on GitHub with good first issue, in case like it's a simple enough feature or simple enough bug fix. And I've included a link out here, and essentially what that helps is if you go on GitHub, and I can quickly share that. If you go on GitHub out here, you will see that there are issues which are marked as good first issue, and they're essentially those where the ramp up time is fair, it's significantly less, and you can get coding and contributing really quickly. Also, we have our own website hosted under the Eclipse Foundation. It's eclipse.org/collections, and we welcome website translations as well. Currently, we have translations for Chinese, Japanese, Russian, French, Portuguese, Brazil, and for German. Of course, English is the de facto website. So if you have any more languages which you would like to add, feel free to add it. The opportunities are literally limitless. Come and get involved, and we will walk you through whatever questions you have, and we will make sure that you'll have a pleasant experience while contributing. Uh, so moving on, what was the motivation behind having another Java collections framework? So firstly, before Java 8 streams came, it was very difficult to write, or rather it was sort of impossible to write functional code in Java. Also, like the API which the standard JDK collections gave were not so fluent, and essentially you needed a way in which you could reduce the pain of a Java developer to code using collections. So that's how that was one. The other aspect of it was the Java collections framework was not as memory efficient, and it's still not. There are a few comparisons which are available. I have published blogs about Unified Map, which is our own map, Unified Set, which is our own set, and then bag multimap, and I've compared it with the memory footprint of JDK. Those blogs are available on Medium, and if you take a look at it, like Eclipse Collections consistently has a lower memory footprint. So essentially, with all of this combined, it led to the invention of this framework, wherein we could actually have functional interfaces before there was support for streams. Like methods like select, collect, detect, all of these were available for us since even before 2012. So even before streams came into existence. Also, we saw that there are some algorithms which can be optimized and which should be optimized. The one example which I always like to give is the summation algorithm. So we have our own primitive collection. So let's say if you take a double list, then if you're having a sum method on that, the sum API on the double list, which essentially sums up all the elements, then in order to reduce the error caused by floating point numbers, we the way we sum it up is by using the Kahan summation algorithm. So essentially, we try to optimize as much as possible. Also, our data structures like maps and sets, they are backed up by flattened arrays, which helps in the iteration versus like actually creating an iterator. So you can just access the array elements. Again, like the Java interop is very important for us because we don't want um, our users to have a really high learning curve. It should be that Eclipse collection should be a drop-in replacement of the JDK collections as much as possible. So what we do is like our collections, most of our collections, I would say, like mutable list, mutable set, mutable map, they essentially extend the JDK list, JDK set, and JDK map, which helps you to actually, in case you're using a JDK map somewhere, you can just drop and replace it with the Eclipse collections map, and you will get the benefits of the memory footprint as well as you will get the benefits of the API. Immutability. This is one of the sort of topics which I feel is interesting from the JDK collections perspective and Eclipse collections perspective. So JDK collections comes with unmodifiable collections. So essentially, they do have the mutating API, but it will throw at runtime. What we have is like we have a suite of our immutable collections, and these collections essentially don't have any of the mutating API available on the interface itself. So what happens because of that is you will get a compile time error, like your code itself will not compile versus throwing at runtime if you are going to call any mutating API. Like for example, our immutable list does not have an add API or a method on it. So since you cannot call that, your code itself will not compile. So it's again like the advantages of compile time error versus runtime exceptions. Um, so moving on, the missing type. So what we did was we essentially we saw there were a few shortcomings in the JDK in the JDK collections hierarchy, and we figured that hey, we can add our own collection types as well. And interval is one, stacks are another. JDK does have a stack, but that's not last in first out. That's actually first in first out because it extends vector. Starting with JDK 6, you have to use the data structure called as deck to essentially use the last in first out uh, feature. However, the Eclipse collection stack is last in first out by default. Also, we have bags and multimaps. Like I actually have published the blogs recently where it compares what a bag is and what a multimap is, and we will see that in live coding shortly. We also have a bidirectional map or a bimap. And then last but not the least is the primitive container. So for all the primitives, all the 7 primitives, we do have their own list, sets, maps, bags, and stacks. So essentially, you will have an int list, int set, int bag, int stack. Now, the interesting thing about map is you always have to do the permutation combination because then it will be int as a key and then rest7 as the value, and then it will be an int as a key and an object type as a value, or it will be an object as a key and int as a value. So we have all of those permutations combinations, and that's one of the reasons why the library has so many lines of code, and we pretty much code generate about 95 to 98% of all our primitive collections code. Mm. So how to acquire Eclipse collections? We publish our coordinates on Maven Central, and the latest version is 9.2.0. We have a 10.0 lined up for September end / October. We generally line it up with one of the conferences so that we can demo new features of the major release. So that's how we generally plan out our major versions. Um, you can get it from Maven Central, and you can also get it for all the Eclipse community or the Eclipse ecosystem, we also publish to the P2 repo. And here I do want to give a big shout out to Gunnar, Karsten, uh, then the Viatra project, if especially Zoltan, if and I apologize if I'm not pronouncing the name correctly, but all of them were like highly influential, and they are the ones who actually got this addition to the P2 repo enabled, because like I mentioned before, we did not have the experience for it with the Eclipse ecosystem. And right now, the latest version, even in P2, is 9.2.0. And starting with Eclipse Photon, will be available in the simrel repo as well. So essentially, if you have a plugin project, you can just add the bundle version as 9.2 and you'll get it. For the builds, again, you can just have your location. And for the Eclipse IDE, if you're delegating it to OOMP, then you can essentially have the target. Feel free to experiment with this, and if there are any issues, or if we again, I'm not going to say we have done this perfectly. Feel free to raise an issue, and better yet, if you feel free to raise a contribution as well, so that we can make sure that our integration with the Eclipse ecosystem is as flawless as possible. uh, Lastly, these resources are all essentially hyperlinks to different web pages of the project, and they will be available on the YouTube link as well. The one thing which I generally tell at all of my talks is, show us your support. It's easy to just put a star on our GitHub repo. Essentially, as an open source project, you always get to know when you're not doing very well, but it's sort of like you don't get the feedback when you're doing really awesome, and getting a star on the GitHub repo is one of the ways in which we get the positive feedback. So feel free to put a star on the repo. And with that, I'm going to conclude the presentation part of it and then move on to the live coding. So essentially, if you go to github.com/eclipse collections dash kata, that's our kata. It's like a learning resource, which I mentioned before. And you can just download the zip file. And once you download the zip file, you essentially get uh, your Eclipse Collections Kata master, and you can just pull this and paste it in your workspace, and you can open the project from a file stream. And this is how it looks like. This is exactly how it will come up. It builds, and essentially what you get is, you do get two different katas. One is the pet kata, and the other one is the company kata. So the pet kata is designed to sort of finish in about 2 to 2.5 hours. The company kata is a bit more longer, which goes on for about 6 to 8 hours. The whole intention is like, you should be able to sort of try out the framework really quickly, and then get the feedback, and then if you want to dive a bit more deeper, you can always use the company kata. So I am going to use the pet cut out here, and as I'm solving the cut, I'm going to go on explaining each of our iteration patterns. And the interesting thing, if you see, is what we have done for ease of actually learning the kata is, we have added Java docs where we are actually linking to the appropriate material. So if I go to exercise 1 slides, it will just pull up out here. And if I go to let's say the mutable list.collect, it will pull up the essential Java doc, so you can always refer to it. Also, we give hints out here. So with that, let me go on solving the first section. So essentially, like I said before, we had the ability of functional programming in Eclipse Collections even before Java 8 streams were implemented. So one of them is actually the transform method. We call it collect. So essentially, when you want to go from, let's say, this is my this dot people, let's say this trying to extract it to demo something. So here I have a list of type person. All right, now I want to go from person and I want to transform it to a list of strings. So essentially what I can do is this dot people, and that method we call is collect. And these method names or these API names are borrowed from Smalltalk, or rather inspired from Smalltalk, and that's where the name collect comes from. This should not be confused by collect, which takes in a collector from the JDK. Now the person, it has a method called as get first name, and that's how you get the first name. And with this, if I were to run, you will see that this does pass. And with this, essentially, we have converted a list of person objects to a list of strings, essentially the list of first names. Now, similarly, we can do it for other objects as well. In this case, it's pets dot collect and then pet uh, get name. Right. Let's run this again. Okay, so get names of Mary Smith's pets. That works fine. Now, this is where things are going to get a bit more interesting, because what we want to do is we want to find all the people who have cats. So if I were to go in my person object or my person class, then you will see that this has a method called as has pet, oh, has pet, which takes in a pet type. So I'm just going to use that, and I'm going to say this dot people dot select, because I need to essentially select those people who have cats, those ones which return true for a boolean. So now here I'm going to pass in a person, and I'm going to say person dot has pet, and then okay. Let me run this, and then we will see a few cool things out here. So this predicate requires you to use a lambda, and that's because this has pet, this method takes in an input. However, like, there are some people, again, this is a personal preference, and I'm one of those where I actually prefer method references, because they are much more concise, they are much more understandable, and they are much more followable. Like, for example, here this get name is on the person class. So it's very straightforward. However, here anyone can name, like, I can just name this to be each, and then you don't even know what each is till you dig down deep in the code. So what we have is we have other set of API, and we call it the width API. And essentially what the width API does is, I'm just going to say select width here, and in the select width, it ends up taking a predicate 2. Okay, and the predicate 2 is essentially a person and another parameter. It's a predicate of a person and a parameter. So for now, let me just add null no, so that this will compile and I can show you the Java doc. So essentially this is exactly same as the select method, except for you pass in a parameter, and that parameter is used while evaluation of that predicate. And this is very important, because what that leads you to, and let me write the lambda form again, right? And person dot has pet, sorry, person dot has pet, and I'm going to just pass in the parameter pet type, and then my parameter out here is going to be pet type dot cat. Now, interestingly, let's rerun this to make sure that the test still passes. The test still passes. Now, if I go over, if I hover over the lambda, what it does is it says that, hey, I can actually convert to method reference. The Eclipse IDE is intelligent enough to understand that, hey, I have a parameter, I have a lambda, and I have a method. And essentially, the way the framework works is, it will say that, all right, take this parameter and pass it as an input to this method. Now this becomes much more concise. Also, you can see, like, the width of the code changes immediately. Now let's run this again to make sure that it works fine. All right. So now this works fine. Now, similarly, when you have people with cats, you also will have people without cats. So we normally what you will have to do with the JDK is you will end up doing this dot people dot select, and then you will have a negative predicate. So basically, you will say not person dot has pet and pet type dot cat. Now this is interesting where it should actually work. However, this not which is there again, like for me, I sometimes find it difficult to actually understand a negation in the Boolean condition, because you always have to, sort of, it becomes interesting while you're debugging or while you're following code. So what we did was we actually have a negation API, which is exactly the opposite of select, which is reject. So when you do the reject, that not is automatically inferred for you. And if I run this now, this will pass. Now, another interesting thing is, like I said before, along with our entire API, we also have the with API. So similar to select with, we will have reject with as well. And now all of this can just be replaced by this predicate. Wait, let's run this. Now, the last section of my showing this API is wherein, let's say it happens that where you want to get uh, people with cats and without cats. So get people cats and without cats. Essentially, you want to run both of these together, right? So I'm just going to copy over the assertions real quick so that we're not writing again. Now, essentially, what you need to do is you need to get the people with cats and people without cats from the exact input. Now, the normal way of doing it will be, this dot people. Again, I can actually literally copy this as well. Uh, you this is the way you'll sort of partition them by some a boolean condition. The ones which satisfy a boolean condition return true will be selected. The ones which do not satisfy a boolean condition will be rejected. So and I sort of gave the clue while I was describing it. We essentially need to just partition this people list. So again, one of the USPs of Eclipse Collections is it does have a fairly intuitive API. So if I were to go into this dot people and I can partition it, and you have partition as well as you have partition with. I'm just going to I'm just going to use the partition with here and use the same method reference out here. Now, what this gives me is let's say partition. Um, Now, this gives me a partition mutable list. If I were to go inside the partition mutable list, it actually is composed of two more. One is the get selected, get rejected. Like I mentioned before, the ones which satisfy the Boolean condition will be under the get selected. So let me get the selected, and then rejected. Now, what this does is you have efficiently partitioned, and the test passes. You have efficiently partitioned the people list by iterating over it just once, and then getting the selected and getting the rejected, versus either having a for loop and then having an if else condition, or just iterating over the same list twice. So again, if you go to the rich iterable interface, and I'm going to sort of just make this to be rich iterable so that it's easier to get inside. So if you go in the rich iterable interface, which is really the base interface for Eclipse Collections, or the most topmost interface in the hierarchy, and if you hit Control O, you will see all the API that is available. and we have like upwards of, I think, 70 odd API, which and we keep on adding more and more. Again, like the interop with Java actually helps us get streams. So in case some people do not want to use this API, they can still use the streams API, and they can get the memory benefits of it. Also, you will see that we have interesting API like select instances of. Then we have the group by API, uh, as well as, so the group by API, as well as we have the count by, and we will quickly look at those two before concluding the session. Okay, so let's look. Let me actually go to exercise 3. All right. So essentially, if you have ever encountered such a pattern where you have an object and you just need to get the counts of that particular object, then there are multiple ways in which you can do it. Like this is the most basic and iterative way, where you initialize a map, you go over your objects, and then you end up checking if that exists. If it doesn't exist, you initialize it to 0, and then you just increment and put. So that is one way. The other way is what we call in Eclipse Collections as a bag. Bag is a data structure which essentially, consider it to be like a shopping bag. Okay, like you have multiple items, and each item, like for example, you'll have 4 apples, 5 bananas, 6 oranges. Then the for every object there is a count associated with it, and we call that as a bag. And if I were to use the pet types out here, I can easily change. So it becomes pet types dot to bag, and this actually gives me what exactly this is doing out here. Okay, so I can completely get rid of all of this, and uh, the code becomes much more concise, where it's just one line. Now, the interesting thing about the bag data structure, again, bag is also called as a multi-set in a few other frameworks, but the interesting thing about the bag data structure is it has its own intuitive API. Like for example, you don't have to like you have to do it for a map. You don't have to do a get and then play the guessing game as what exactly that get is returning. Rather, it has much more of an intuitive API where you are saying that, okay, get me the occurrences of. Also, you have another API called as, add occurrences, like bounce dot. This should be a mutable bag. Again, like I said, we have our own, the whole interface hierarchy which is there. So since I need a mutating API, which is to add counts, I can just either add a pet and then just do pet type dot cat, or I can do counts dot add occurrences, and then my item is pet type dot cat, and my occurrences will be, let's say, 5. I want to add 5 more cats. It's, like I mentioned, again, like a bag is similar to your shopping bag, where you might have multiple fruits or multiple objects, and or if you have more than one of the same object, all you're doing is, let's say at the checking counter, you'll have more than one occurrence of that particular object. With that, I'm going to move to the last section of, or the last, demo of my talk. Essentially, where you want to associate more than one value to a key in a map. So you want to have a multi-valued map, or as we call it, it's a multi-map, where one key is associated to a collection of values. Now the collections can be anything. So the collection can be a list, it can be uh, a set, or it can be a bag. The most important thing is, if the collection is a list, the values should maintain order. Okay, if collection is a set, the values should only retain unique elements. Also, the lookup should be O1, etc., etc. If the collection is a bag, it values should allow duplicates like a multiset and provide ability to count / get occurrences. So essentially what I'm trying to say is like the value collection which is there, that should be semantically true to its backing collection. Now what ends up happening here is let's take the JDK for example. Like when you this is similar to you grouping by your last name. So you have a list of person objects and you're grouping by the last name. Now what ends up happening here is fine. It's very like it's very straightforward for you to, I mean, this is too much code, but however, you can say that it's straightforward for you to create this multimap. Okay, you can say string mutable list person. However, the problem comes is when you want to add something, let's say last names to people. If I want to put, okay, now I have to put, this is a string, so let's say it's a Smith, okay, and my second argument has to be a mutable list, because if I just say new person and I pass in a null out here just for compilation sake, uh, this method will not compile because it says the value has to be a collection, it has to be a mutable list. So what we did at Eclipse Collections is we basically created our own data structure. We call it a multimap. I'm going to comment this for a minute. And essentially what the multimap does is it's similar to your SQL group by, where I can just do this dot people dot group by, and I'm going to group it by the last name. So person get last name. And since I do want to show the mutating API, I'm going to convert this to a mutable multimap. Let's import that, and then let's actually run this run this test. So there you go, people by last name. This does work fine. Now the interesting thing is what I had shown here before, where it is a compilation error because my values have to be a collection, versus if you see by last name multimap out here, I can just do a put and I can do a Smith and I can say new person, null. Now the interesting thing is this one compiles, and if I were to duplicate this line, this should work fine because I've essentially delegated it to the framework and it works fine out here. I've essentially delegated it to the framework to do what is necessary, wherein like they have to the framework has to get the correct backing collection and add to that collection which is associated with the key, and that's a multimap. So with that, I'm pretty much towards the end of my live demos. I can take in questions if there are any.
Thanks, Nikhil, for a fantastic demo and presentation. At this time, we don't have any questions, but we will be monitoring our YouTube and comment section, our Twitter feed, Meetup page. So if anyone has any questions, feel free to drop them there. And again, I would just like to say thank you to Nikhil for presenting. It was a fantastic demo and webinar. And we will see you tomorrow for our next webinar, What's New in Eclipse Vayatra 2.0. So thanks, everyone.
Thanks, Stephanie. And I do want to sort of end it with the resource page which has all the links, and also, like I said before, show your support, put a star on our GitHub repo. Thanks a lot again for watching the webinar.
Absolutely. And you can find all of those links and resources in the description down below in this video. So thanks again for tuning in, everyone. We'll see you tomorrow.